Hello everyone, welcome back to Express Video for All. Today we are going to solve a very important question from Module 1 Finite Automata. This question may ask in video examination. So the question is very important. So convert the following epsilon NFA to DFA. In this question, we have a transition table, epsilon NFA transition table. So we have to convert this epsilon NFA to DFA. So what we will do firstly we will make this transition table to a transition diagram. So here P is the initial state, R is the final state. This is initial, this is final. With the P input symbol A, it is going to P itself. This is a self loop with A. Like that, P with input symbol B, it is going to Q. P with input symbol C, it is going to R. See, like that we have to make the transition diagram firstly. Then what we will find? We will find E closure of every state P, Q and R. So what is E closure? E closure of P is nothing with the help of this one E epsilon, where we can reach to another states. Like with the P there's not any outgoing epsilon, there is epsilon Q to P but not at P from where we can go to another state. So here this will be P only. Like that we will find E closure of Q. At the Q state, there is we can reach to Q itself, and also there is an epsilon input symbol, it is going to P. So we can write it like this one, and also P comma Q, both are same. Now we will find E closure of R. So here R itself, this can be accessible, and with the input symbol epsilon, it is also accessible to Q, and from Q to P. Like that we have firstly find the E closure of P, Q and R. Then what will be our next step? Next we have to draw the transition table for this. So after finding the E closure of P, Q and R, we have to make a transition table, DFA transition table. So here how we will get that? We will write here transition input symbols A, B and C, not epsilon, only A, B and C is there. Firstly we will take this one with the help of P, where we can reach. So P, it is accessible only with A on the P only, like that P. Now with P, P and Q, P and Q, with the input symbol C we can reach to P to R, R to Q with the help of epsilon. So P, Q, R, all of this can be accessible with the help of epsilons. So now next hour is we will take a new combination of pairs here. So we have taken this one P. Now P comma Q is new one. So we will take this one P comma Q. So now we will check P as well as Q on the input symbol A. So P with the input symbol A itself it's coming P, and also we will check at Q with the input symbol A. So it's P comma Q. Now with the same with the input symbol B, P with B it's going to Q, P and Q, and at the Q with the B it's also accessible to R. Like that P with the input symbol C, R and C with the help of epsilon we can reach to Q. So P, Q and R. Like that now we have another pair P, Q and R. So we will take this one P, Q, R. So all of these will be accessible. P, Q, R. Here also P, Q, R. P, Q, R. So now we get the transition table for the DFA. Now we will convert this into TFA diagram. Let us take P as an A, P comma Q as an variable B, and P comma Q comma R as an variable C for our simplification. So now our transition diagram will be like this. A, this is A. With the input symbol A, it is coming to itself. A. Now, with the input symbol B, it's going to PQ. PQ is B. So B. P with this input symbol C is going to PQR, which is nothing but C. Now we will come to P comma Q, which is B. With the input symbol A, it's a self loop A, and here it will go to B and C, B comma C, and then the C with the input symbol A, B and C all are self loop. So here A comma B comma C, and here C is the final state. So like this we have to do, convert the following epsilon NFA to DFA. So the transition table will be given and we will directly form the transition diagram of epsilon NFA. Then we will find the E closure of P, Q and R. Then finding new pairs and getting the transition table for the DFA. Now we will put all the DFA transitions to the diagram. Like that we can find the NFA to DFA. So thank you for watching our video. Please subscribe Express Video for all.